In this question, we've got oxygen which is reacting with C₂H₆. So it's reacting with this hydrocarbon, and we've got CO2 and H2O produced by that reaction, right? And we've got the balance equation here. And we've effectively been asked, well, what's the volume occupied by the carbon dioxide produced from the reaction? Right, so how am I going to approach that? Well, in order to really work out the volume, I need to first work out the amount of substance of carbon dioxide that's produced in the reaction. And working backwards from that, I can work that out from the balance equation, but in order to do that, I need to work out one of the amount of substances of one of these produced. At least I would want to focus on a limiting reagent, and in this case the limiting reagent we've been told actually is oxygen, right? Because the C₂H₆ is in excess, right? So obviously O2 based on that is going to be the limiting reagent. So I would need to work out the amount of substance for the oxygen, right? So I'm going to use the equation that the mass is equal to the moles n multiplied by the molar mass, right? And that would, in effect, if we rearrange that, we get that by dividing both sides by mr, right? So by doing that, we're going to get that the number of moles is equal to the mass divided by the molar mass, right? And specifically in relation to oxygen, we have the mass from the question, right? The 47.45. But what we don't have is the molar mass. So we need to get this from the periodic table. So for O2, if we're looking at the mr for O2, you can see here that the relative atomic mass for oxygen is 16, right? And so the mr for O2 is going to be 16 multiplied by 2, right? Because there's 2, O2. And that's going to give us 32, right? And that's going to be 32, and that's going to be in grams per mole, right? So now we have both. We've got the mass and we've got the molar mass, right? So we've got the 32, the molar mass value, right? Okay. What we need to work out now, if we basically take these values, right, and calculate it, this will give us the number of moles of the oxygen, right? So we can say the number of moles of the oxygen is going to be equal to 47.45 divided by 32, right? And if you do have a go at working that out, you should find that you get 1.48 28 125, and that's going to be in moles, right? Okay, so we've got the number of moles of the oxygen. We've got a value for that, but what we need to do is work out the amount of substance of the carbon dioxide. All right, so this is the oxygen. So by using the balance equation here, comparing the oxygen and carbon dioxide, we can set up a bit of a ratio. We can say that for the we can say when we compare the number of moles of oxygen as a ratio of the number of moles of carbon dioxide, the ratio is 7 on this side to 4 on this side, right? And if we divide both sides to try and get this side to be a 1, we get that effectively it's going to be 7 over 7 as ratio to 4 over 7, right? So basically what this means is that for every 1 mole of oxygen, O2, we're going to get 4 over 7 moles of CO2, right? So what does that tell us? Well, that tells us that the number of moles of CO2 is equal to effectively 4 over 7 multiplied by the number of moles of oxygen, right? So, and we have the value for the number of moles of oxygen, right? So we can just effectively say, okay, well, the number of moles of CO2 is equal to 4/7 multiplied by this value that we have here, which is 1.4828125, right? So if you do have a go at working that out, you should find you get 0.8473214, right? And that's going to be in moles, right? Moles. And recall that the question actually asks us, well, work out the volume occupied specifically at room temperature and pressure by the carbon dioxide produced from the reaction. Well, at room temperature and pressure, as you can see, 1 mole of any gas is going to occupy a volume of 24 decimeters cubed, right? So effectively for this, we can work out the volume occupied by multiplying this value by 24. So therefore we can say that the volume, right, not the number of moles, the volume of CO2 is going to be equal to 24 multiplied by the value of the number of moles we got for carbon dioxide, so 0.8473214, right? And that's going to be 20.3357136, right? And that's the units of that is going to be in decimeters cubed, right? And that's going to be well, let me explain why I'm doing this next step, right? So if you pay attention to what the question says right at the end, it does specify to give the answer to a maximum of 2 decimal places, right? So that is effectively what I'm trying to do at this stage. I'm trying to make sure it's to 2 decimal places, right? So the answer is going to be 20.34 decimeters cubed, right? That's the 2 decimal places, right? So as you can see, I just basically rounded that up, right? Okay, so yeah, that's going to be our volume in this case.